Hey math enthusiast, I'm here to go over some problems from section 6.1 which relates to ratios, proportions, and geometric mean. For these first couple problems, all they're asking us to do is simplify the ratio. Now, before I can simplify these two values that they give me, first I want to make sure they're in the same units. So if you remember what I said from the notes, I always want to change them both to whatever's smaller. All right, quarts are smaller than gallons, so I'm going to keep this as 10 quarts, and I want to change the 3 gallons so that one is also quarts. Well, there's 4 quarts in 1 gallon, so that means there's 12 quarts in 3 gallons. So I have 12 to 10. I can divide both of them by 2, so my final ratio would be 6 to 5. That's supposed to be my colon in between, and then my units are quarts. For the next couple problems, I need to find the ratio of AB to AC in simplest form. So I'm going to jump to B over here. So as they told me, I want a ratio of AB to AC in simplest form. So first let's figure out where these values are in my picture. So we have AB, that's 57, and I have AC, which is this entire length, which is going to be 57 and 38 together, which is going to give me 95. And they're both in meters. And then I just want to try to reduce that if I can. And it looks like I can actually divide both of them by 19. So my final answer is going to be 3 meters to 5 meters. For this next problem, I'm dealing with area of a rectangle. So they tell me that my area is equal to 525 centimeters squared. And remember that your area is going to be length times width. Because then they go on, they give me my ratio for length to width is 7 to 3. So 7 for my length and 3 for my width. So I want to figure out what exactly is the length and the width. So if you remember, it's not going to be exactly 7 and 3 for my side lengths. It's 7 times some value, and it's 3 times some value. All right, so maybe it's like 14 and 6. But the thing is, they have to equal 525. So that's what I'm going to do. I'm going to set up my equation. So I have 7x to represent my length, 3x to represent my width, and it's going to be equal to 525. Well, when I multiply these together, I get 21x squared equals 525. When I divide by 21, I'm going to get x squared equals 25. So that tells me x equals 5. All right, my final answers are actually over here to the right. So my length is going to be 35 centimeters and my width is 15. And I can always check that if I multiply those two together, 35 times 15, and it is going to give me that 525. Next problem is a very similar setup. The only difference is now they're giving me the perimeter of my rectangle. So the perimeter is equal to 132 inches, and I know that my formula for perimeter is double the length plus double the width. So the distance all the way around, 2 lengths and 2 widths. And then they give me my ratio. My ratio of width to length, so the 7 represents my width, the 4 represents my length, and I got to figure out what those are if my perimeter is 132. So remember, it's not going to be exactly 7, it's not going to be exactly 4, but it's some multiple of 7, and it's some multiple of 4. So I'm going to plug them into my equation here. So right now I have 132 is equal to 2 times the length, which we just said is 4x, some multiple of 4, and 2 times the width, which we just said is 7x, some multiple of 7. So I'm still going to have 132. I'm going to have 8x and 14x. So 132 is going to be equal to 22x. And lastly, x is going to equal 6. And then I have my final answers over here on the left. So 42 represents my width, and 24 represents my length. And if I were to plug them into my equation up here, I would get 132. For the next problem, now I'm dealing with an extended ratio. So there's three different values I'm comparing. And these represent angles in a triangle. That's important because I know that the angles in a triangle are going to add up to 180. So much like the problems before, my angle measures aren't 7, 16, and 22 because those do not equal 180. All right, but what I do know is that it's some multiple of 7, some multiple of 16, and some multiple of 22. So what I'm going to do is I'm going to set up an equation. So it's going to be my one angle plus my second angle plus my third angle equals 180. So I end up with 45x equals 180. Divide that by 45 and x equals 4. So when I plug that back in, it looks like my final angle measures are going to be 28, 64, and 88. And I know that's correct because those three together add up to 180. And if I divide all of these by 4, what that's going to do is that's going to bring me back to my original ratio, 7, 16, 22. So for these next couple problems, you have to solve the proportion. You're essentially just solving for x. So I put up solutions for 8 and 9, and I'm actually just going to jump to number 10. All right, now when you cross multiply, obviously you're going to have 7 times 5 on the one side. But on the other side, you're going to have x plus 1 times x minus 1. So I'm going to end up with 35 equals, and then you just got to remember to FOIL this. So I'm going to have x squared minus 1x plus 1x minus 1. Now, as soon as I start to combine my terms, I notice that my negative x and positive x cancel out. I'll move this one over to the other side, which gives me 36 equals x squared. And then the last thing I need to do is just take the square root. So technically I end up with a positive and a negative. And in this case, both of those solutions will work. All right, even if you do end up with a negative in your proportion, it's still equal. All right, so we're not talking about side lengths, so you can have a negative value. Next couple problems, I'm dealing with geometric mean. So remember, this is your A value, this is your B value. So when you set up the proportion, it's going to be A over X equals X over B. So I'm essentially going to have 3 over X equals X over 27. So this is going to give me X squared equals 81. And then I'm going to take the square root of that, which gives me x equals 9. Now, some of them you're not going to get a perfect value or a whole number for. For number 12, it's not going to be a whole number. But for number 13, you will get a whole number. Now, for number 14, they want two pairs of numbers whose geometric mean is 10. So what I'm saying is at the end, my solution is 10. So I'm trying to figure out what's my A and B value that I started with. So think about the equation that we had up here. So it was A over X equals X over B. What A and B could I plug in here that would lead me to get 10? So remember, I'm going to cross multiply. X squared equals A times B. Well, if X is 10 down here, that means that X squared equals 100. So essentially what I'm just asking is, if I replace this with 100, what two numbers can I multiply together that would give me 100? So you could do 101 if you wanted to. You could do 50 and 2. You could do 25, 4. You could do 25. All right, multiple different choices. They really only asked for two pairs, though. For the next couple problems, they give you a ratio, and they want you to solve for the variable or variables that you're dealing with. So let's jump to number 16. So they give me an extended ratio, xy, yz, xz, and then 7 to 10 to 14. Okay, well, I can't really set up a ratio into a proportion and solve if I have 3 different terms. So let's just focus on the first 2. So what I'm going to do is I'm going to rewrite it as a proportion, as I said. So xy over yz equals 7 over 10. Okay, now in my picture they give me more information. They give me a length for xy and yz. So I'm going to erase them, and now I'm going to replace them, xy with b minus 7 and yz with b plus 20. Okay, now I have a proportion set up. I have my variables that I'm looking for. Now I can just go through, cross multiply, and solve. So I'm going to have 10 times b minus 7 equals 7 times b plus 20. So I have 10b minus 70, 7b plus 140. So I'm going to end up with 3b equals 210, which tells me that b is going to equal 70. So I have b equals 70. So now let's move on and try to solve for c. So that means I'm going to have to use this last part of my extended ratio. So let's focus on the second and third values this time around. So I'll set it up with my side lengths first. So we got yz and xz is going to equal 10 to 14. So now I'm going to go back and I'm going to change these values. So we have a length for yz and we have a length for xz. So xz is 5c minus 24. And then for yz here, I know that b is 70. So I can put 70 in here instead, which tells me that yz is actually 90. So from here, now that my proportion's set up, now I can cross multiply and solve. So I'm going to have 90 times 14, and then I'm going to have 10 times 5c minus 24. So I have 1,260 equals 50c minus 240. So it looks like after I add the 240, I'm going to end up with 1,500 equals 50c, which means c equals 30. So now I have both b and c, and that's all they were asking for. For the next 2 problems, you're just plugging in the values that they give you and just simplifying it as best you can. So for example, for a, I'm just going to replace x with 8. I'm going to replace y with 6. I'm going to replace z with 5. And it's all over 2 times y. So first thing I'm going to do is add these 2 up. Gives me 14 minus 5. So my new numerator is going to be 9 over 12. Last thing I want to do is just reduce that as much as possible. Divide both my terms by 3, which gives me 3 to 4 for my final ratio. Now, this next problem deals with a scale model for the Golden Gate Bridge. So they're telling me my scale is 1 inch to 50 feet. So for every 1 inch on the model, it's going to be 50 feet in real life. Now, they tell me that the actual length of my bridge is 8,980 feet. So I want to figure out first, what is the length of the model? Okay, so right now my ratio is comparing the model length to the real thing. So model to real. And the ratio is for every 1 inch on the model, it's going to be 50 feet in the real thing. So I'm going to continue this ratio, and what I want to figure out is the length in the model. So I'm going to put x here because I want to figure out what is it in the model. If I know that the real length down here is 8,980. Now, since my ratio is already set up in inches and feet, then I really don't need to change them to the same units, because I know that my numerator up here, where x is going to be in inches. So what I need to do now is just cross multiply. Well, I'm going to have 8,980 equal to 50x. So now I'm just dividing it by 50. So x equals 179.6, and I already determined earlier that those units were going to be inches. So for the next problem, it's going to be a similar setup. So I'm still using the same ratio, the model to real life, which is 1 inch to 50 feet. Now for this problem, they tell me the height of the model. So they're telling me the model is 15 inches tall. So the model, for every 1 inch, in this case 15 inches for the height, I'm trying to figure out what is it in real life. So this is where my x is going for feet. As soon as I have my proportion set up, now I just cross multiply and solve. So x is just going to equal 750, which gives me feet as well for the units.